Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Alright, today we are going to talk about equilibrium constant Kc. For the C, it stands for concentration at equilibrium. Whereas the K stands for constant. Okay, so you need to know only liquid and gas can have concentrations. So we are going to ignore all the solid. Alright, I give you more example about this later. So let's say if we have this general equations, we're going to express this equation in this form whereby we have to write Kc equals to product over reactant, where the small letter C, D, A, B are their stoichiometry respectively. Okay, I'll give you an example for this right now. So look at this exercise. Write the expressions for the Kc and its units. So first of all, we're going to look at the states symbol of it. So all of them are gas, which means we have to express all of this in the Kc expressions. So Kc will be equals to Hi, which is the product. We have the square here because of the 2 here, over H2 and I2, okay? And their stoichiometry here is 1 and 1, so therefore both of this is to the power of 1. So in order to look for the unit for this, we'll have to see, since there's 2 concentration term, it will be mole per dm cubed square. Over here, there's 2 concentration term as well, so over here will be mole per dm cubed square. Hence, this 2 unit will be cancelled off and therefore it will lead to no unit. Alright, now let us look at the second one. So if let's say we have this state symbol, okay, we are definitely going to ignore this solid because it doesn't have any concentration. Alright, so therefore we have to write it like this. Kc equals to product, which is the H2CO, over the reactant, which is H2O only. Alright, so in order to come up with the units, we will have to see there are 1, 2 concentration term. And the concentration unit is mole per dm cubed. So since 2 concentration term, it is to the power of 2 over mole per dm cubed. Alright, so this is also the unit will not be cancelled off, so that will left with mole per dm cubed. Alright, and for number 3, this one is Kc equals to SO3 square, because this is 2 here, over SO2 square because of this, and O2. So the unit for this will be mole per dm cubed square over mole per dm cubed cube. Why is that cube? Because there are 3 concentration term over here. So if you expand this, you will get mole square dm negative 6 over mole cube dm negative 9. So ended up, you will need to use mole. 2 minus 3 equals to minus 1. dm negative 6 minus 9, you will get 3. So this is how we express their Kc expressions and also the units. Okay, now let's look at the questions regarding about Kc. Now imagine this is the equations given Okay, the initial amount of A and B in 1 dm³ solutions are 1 mole and 0.75 mole respectively. At equilibrium, 0.7 mole of A remains unreacted. Calculate the equilibrium constant for this fraction. In order to solve this kind of questions, we will always need to build an ICE table. We call it ICE table. Well, you need to understand the I stands for initial, where initial is the initial mole or the mole given. This is mole given. Okay, well, the C stands for change, where change means the mole reacted or the mole formed. Alright, and E stands for equilibrium, where equilibriums means the mole left or the mole form. Okay, so for example, in these questions, the mole given, which is the initial mole given, is 1 and 0.75. So I'll fill up here 1 and 0.5. 0.75, sorry. Alright, so initially there's nothing in C. Alright, now if you look at the changes, it says that at equilibrium 0.7 mole of A remain unreacted. When we see remain unreacted, that means it is not reacted. Remain unreacted means that is left. So 0.7 should be filled up over here, 0.7. Okay, so there's no more information given. So from here we can actually solve the whole table. So in order to solve the whole table, we will need to see how much reacted in order to get this much left. So it should be minus 0.3. And please note that this second row over here is related to the mole ratio here. This is 2, this will be 1, and this will be 1. So if, let's say, now this is 0.3, the changes here will go according to the mole ratio. If this is 0.3, hence this will be 0.15 because it is 2 to 1. Hence 0.3, 0.15 of B will be reacted. Okay, and how much would it form? It will be plus 0.15 because it is all going according to the mole ratio. Only the second row here followed the mole ratio over here. So with this you can calculate that this is 0.6, and for this 0 plus 0.15 equals to 0.15. Okay, and all this is in terms of mole, and therefore we'll have to change it to concentrations in order to sub into the CAIE expression. So for my CAIE expression, CAIE will be equals to the concentrations of product over reactant, where we have A to the power of squared and then B. So my C is 0.15 divided by 1. This is the concentration. This is just a mole. In order to calculate concentration, it is mole divided by volume. Okay, so then we have this. For A, this is 0.7 over 1 by square and 0.6 over 1. Alright, hence you're going to get 0.51. But in order to work out the unit, this is just mole per dm³, but now here is mole cube dm-9 because there are 3 concentration terms in total. So the final units will be mole 1 minus 3 will be equals to minus 2 dm, negative 3 minus 9 will be 6. Okay, so this is how you solve this question.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.